Good day, I am Varon13. I will report the topic of chemistry and let's start in Module 1. Module 1. Review of Basic Chemistry. The introduction, fundamental and derived quantities in the chemistry that need various measurement, computation are covered in Module 1. Teaches pupils about the characteristic of each element in the periodic table, both chemically and physically, and introduces them to the structures of an atom. Students will be able to determine an element's place in the periodic table based on its atomic number through in-depth taxon presentation. Additionally, they will be able to compute the theoretical yield reactant and product quantities and product yields from balanced chemical processes. As a way to analyze and evaluate the knowledge they have gained, students will be given experiment and activities to complete. Measurement. Different types of measurement are used in chemistry, calculation, and quantities. A number and the unit make up every measurement. The kind of dimension that serve as a foundation for comparison is described by the unit. The number indicates the quantity or numbers of reference units contained in measured quantity. Measuring expertise will be necessary for engineers in the future to solve real-world engineering issues. Measurement is the process of associating numbers with physical quantities and phenomena. System of measurement. System measurement refers to the process of quantifying and assessing various aspects of a system to understand its performance, efficiency, and other characteristics. System of measurements refers to the process of associating numbers with physical quantities and phenomena. Metric system. Scientists use the metric system as their standard unit of measurement. Length, mass, temperature, time, amount of material, electric current, and luminous intensity are the 7 basic metrics now in use. Because they originated from combination of these 7 fundamental base units, derived units get their name. The basic units of measurement for length, mass, and volume are meters, kilograms, and liters respectively in the metric system. Degrees Kelvin or degrees Celsius are used to express temperature. Due to its ability to link fundamental units to other subunits in the multiples of 10, such as 10, 10 or 1000, the metric system is also centi, milli, which denote 1 over 10, 1 over 100, and 1 over 1000. Respectively, of the designated unit, a larger unit 1000 times the fundamental unit, 1 kilometer is equals to 1000 meters. Is indicated by the prefix kilo, another unit of length that is frequently used to indicate the atom. Size is angstrom. 1A is equals to 10 minus 10 m. Metric system, a system of measurement in which the basic units are the meter, the second, and the kilogram. English system. The fundamental units of measurement in the English system are the foot for length, the pound for mass, and the quart for volume. Fahrenheit degrees are used to measure temperature. English system, a system of weights and measurement based on the foot and pound and second and pint. Density and specific gravity as the mass in a relation to the volume Equation 2 minus 1 illustrate the density equation with P, M, and V standing for density, mass, and volume respectively. Density is commonly measured in gram per milliliter, kilogram per meter, gram per cc, kilogram per liter, and pound per feet. Density is defined as mass per unit volume. It has the SL unit kilogram, meter raised to negative 3 or kilogram over meter and 3 and is an absolute quantity. Atomic structure. The atomic structure refers to the organization of protons, neutrons, and electrons with an atom. Nucleus. At the center of the atom, the nucleus contains the protons and neutrons. Protons, positively charged particles. The number of protons, atomic number, defines the element. Neutrons, neutral particles that add mass to the atom and can affect its stability. Electrons, negatively charged particles that orbit the nucleus and regions called electron shells or energy levels. Electron shells. Electrons are arranged in the shells around the nucleus. Its shells can hold a certain maximum number of electrons. Valence electrons. Electrons in outermost shell, which determine the chemical properties of an element. An atomic comprises three different particles known as protons, neutrons, and electrons. The protons and neutrons come together in the center of the atom to form the nucleus. Electron configuration. Along the shells or energy levels, electrons circulate throughout the nucleus. Sharp, primary, diffuse, and fundamental are the subshells that make up its main energy level. The electrons fill the orbits of energy levels in accordance with the following principle. According to Paul's exclusion principle, an orbital can only hold two electrons. Of Bohr's principle proposes an order for sublevel occupancy. Of Bohr principle is guided by the mnemonic device 1 to 3 when filling in orbitals. According to Hund's rule, electrons are initially arranged in separate orbitals for each sublevel. Before partnering, this is due to the fact that it appears that an electron requires level energy to inhabit a free orbital than an orbital that already has an electron. The arrangement of electrons in orbitals around an atomic nucleus. The electronic configuration of an atom in the quantum mechanical model is stated by listing the occupied orbitals in order of filling with the number of electrons in each orbital indicated by superscript. Stoichiometry. Stoichiometry is a branch of chemistry that deals with the quantitative relationship between the reactants and products in a chemical reaction. It is based on the principle of the conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. The relation between the relative quantities of substances taking part in a reaction or forming a compound, typically a ratio of whole integers. And mole. The mole is a fundamental unit in chemistry that measures the amount of substance. 1 mole is defined as exactly 6.02214076 times 10 raised to 23 entitles atom, molecules, ions, or other particles, a number known as Avogadro's number. The mole is a unit of measurement that is the amount of pure substance containing the same number of chemical units. Empirical and molecular formula. The empirical formula of the compound shows the smallest whole number of atoms of each element present in one molecule of the compound. It is also known as the simplest chemical formula. For example, the simplest formula of hydrogen peroxide H2O2, which is used as bleaching agent for hair and textile, is HO. The molecular formula of the compound shows the actual number of atoms of each element present in one molecule of the compound. It consists the symbols of the element and the subscripts in back. The subscript numeral indicates the number of atoms of an element present. There is no subscript for Ba because there is only one atom of barium in a molecule of barium chloride, and the number 1 is no longer written. Empirical formula show the simplest whole number ratio of atoms in a compound. Molecular formulas show the number of each type of atom in a molecule. And now, continue to Module 2. Thermochemistry. Thermochemistry is the study of the heat energy involved in chemical reactions and physical transformations. It focuses on the energy changes that accompany chemical reactions, particularly the exchange of heat between the system, the part of the universe under study, and its surrounding. Thermochemistry is the branch of chemistry concerned with the quantities of heat involved or absorbed during chemical reaction. Calorimetry and heat capacity. The science of measuring heat is called calorimetry. When a body receives or releases energy as heat, the measurement is based on the change in temperature. Different substances react differently to heat. To raise the temperature of substance by 1 degree, a significant amount of heat energy is needed. It's possible that some compounds need less or no heat energy. The substance's heat capacity, Cp, serves as an indicator of this characteristic. The amount of energy needed to increase a substance's temperature by 1 degree Celsius per gram or mole is known as its heat capacity. Calorimetry is the science of measuring the heat of chemical reaction or physical changes. Related terms, heat capacity. This is the amount of heat needed to raise the temperature of an object by 1 degree Celsius. Enthalpy of changes in temperature. The enthalpy change due to temperature changes can be determined using heat capacity of a substance. For a constant pressure process, the enthalpy change delta H can be calculated using the following equation. Delta H is equals to Cp delta T, where delta is H the change enthalpy, Cp is the heat capacity at constant pressure. Delta T is the change in temperature. If the heat capacity Cp is temperature dependent, and the equation becomes an integral. Delta H is equals to int plus d plus 21 raised to t plus 2 Cpt dt, where t and t2 are the initial and final temperature respectively, and Cpt is the heat capacity as a function of temperature. Enthalpy change is defined as the heat exchanged during a chemical reaction. Enthalpy is the amount of energy in a reaction that could be theoretically released as heat enthalpy change can be thought of as the heat required for a reaction to the occur. Enthalpy of phase change. The amount of energy required to change the phase of a substance from one state to another at constant pressure and temperature. Common phase changes include melting, fusion, boiling, vaporization, and sublimation. The amount of energy required to change the phase of a material is known as the enthalpy or latent heat for that phase change. Its SL units is joule. Heating a solid causes its molecules to vibrate more, thereby increasing the temperature of the solid as predicted by its specific heat. Calorimetry experiment. Calorimetry problems include two categories. The first category has substances with different temperatures but no chemical reaction occur. Two substances each at different temperature are combined and allowed to reach thermal equilibrium. The energy released by the warm object is absorbed by the cool object. Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction by knowing the change in heat. It can be determined whether or not a reaction is exothermic, releases heat, or endothermic, absorbs heat. Standard enthalpy. Enthalpy H is the heat content of a substance. The enthalpy change AH refers to the change in heat content due to chemical reaction. At constant pressure, the reaction is exothermic when the enthalpy of the reactants is greater than that of the products. The reaction is endothermic when the enthalpy of the products is greater than that of the reactants. Standard enthalpy of reaction delta HR is the enthalpy change that occurs in a system when the matter is transformed by given chemical reaction when all reactants and products are in their standard states. Standard enthalpy of formation. The standard enthalpy of formation delta H F circ of a compound is defined as the enthalpy change when 1 mole of the compound is formed from its elements in their standard state, the most stable form of the element at 1 bar pressure and specific temperature, usually 298.15 K or 25 degrees Celsius. The standard enthalpy of formation is a fundamental quantity in the thermodynamics and can be used to calculate the enthalpy changes of chemical reaction. The standard enthalpy of formation of pure elements in their standard state is 0. And next, Hess law. Hess law states the change in enthalpy is always the same whether the reaction is performed directly or whether it takes place indirectly in the different step. The total change in enthalpy is the sum of all changes in multi-stage reaction. Hess's law of constant heat summation, the law states that the change in enthalpy for a reaction is the same whether the reaction takes place in one or a series of steps. First law of thermodynamics. The first law of thermodynamics states that energy is neither created nor destroyed. However, energy can be converted from one form to another. Another way of stating the first law is that the energy of the universe is constant. The first law of thermodynamics states that energy can neither be created nor destroyed, only altered in form. For any system, energy transfer is associated with mass crossing the control boundary, external work, or heat transfer across the boundary. Second law of thermodynamics, also known as the law of entropy. Entropy is the disorder or randomness of the system. It is measure of how matter and energy are dispersed. Over time, the entropy of the universe always increases if there is a change in phase from a solid to liquid to gas, or if there is a change in size from large molecule to small molecule to atoms. There is an increase in entropy because matter is moving farther apart. The concept of entropy is better understood using example. Liquid water at 0 degrees Celsius has higher entropy than ice at the same temperature. A quantity of gas contained in a 1-liter flask has higher entropy than the same quantity of gas confined in a 10 milliliter flask. The change in entropy AS is the sum of the absolute entropies of the products minus the sum of the absolute entropies of the reactants at standard condition. The second law of thermodynamics says in the simple term, entropy always increases. Gives free energy. Gives free energy, often denoted as G, is a thermodynamic potential that measures the maximum reversible work that can be performed by a system at constant temperature and pressure. It combines enthalpy H and entropy S and temperature T in the following equation: G equal H minus Ts, where G is the Gibbs free energy, H is the enthalpy, T is the temperature in Kelvin, S is the entropy. The Gibbs free energy is the available energy of substance that can be used in chemical transformation or reaction. And let's continue to Module 3, Electrochemistry. Electrochemistry is a branch of chemistry dealing with the interchange of chemical and electrical energy. It involves chemical reaction, producing electricity, and changes associated with the passage of electric current through matter. It is primarily concerned with the two processes that involve oxidation reduction or redox reaction. Almost all devices use battery for powers, like for example, mobile phone, pacemakers, watches, and even automobiles, as in the case of electric vehicle, which can be recharged because of the use of batteries, hence using electric energy to produce chemical change and vice versa. Electrochemistry is the study of electricity and how it relates to chemical reaction. In electrochemistry, electricity can be generated by movement of electrons from one element to another in one reaction, known as redox or oxidation reduction reaction. Oxidation number. The oxidation number is a positive or negative value that not only describes the combining capacity of an atom but also indicates how many electrons are arranged in a compound. These oxidation numbers are assigned according to electron structure and electronegativity for several key elements. Oxidation number. An oxidation number is a number that is assigned to an atom in a substance. The oxidation number could be positive, negative, or zero, and this indicates for electrons are lost or gained. In other words, the oxidation number is a number that helps us keep track of electrons in an atom. Oxidation-reduction reaction. A redox reaction involves reduction and oxidation, thus the term redox. It is a reaction that contains a change in oxidation state of one or more elements. Electrons move between atoms in redox reaction. Oxidation is the loss of electrons when a reactant is oxidized. It is referred as the reducing agent Leora. The loss of electrons results to an increase in its oxidation state. Reduction is the gain of electrons when a reactant is reduced. It is referred as the oxidizing agent GERA or GERA. The gain of electrons by the atoms results to a decrease of oxidation state. Oxidation-reduction reaction, commonly known as redox reaction, are reactions that involve the transfer of electrons from one species to another. Galvanic cell. A galvanic cell or voltaic cell is an electrochemical cell where chemical energy is transformed into electrical energy. The electrode compartment in which oxidation occurs is called the anode. The electrode compartment in which reduction occurs is called the cathode. What is galvanic cell? An electrochemical cell that converts the chemical energy of spontaneous redox reaction into electrical energy is known as galvanic cell. Is an electrochemical cell that makes use of chemical reaction to generate electrical energy. Cell potential. A galvanic cell consists of oxidizing agent in one compartment that pulls electrons through a wire from reducing agent in the other compartment. The pull or driving force on the electrons is called the cell potential cell or the electromotive force EMF of the cell. The unit of electron potential is the volt, which is defined as 1 joule of work coulomb of charge transferred. The voltage of the cell is the sum of the oxidation potential and the reduction potential. That superscript denotes standard state condition when all cells are 1 m and all gases are 1 atm. Cell potential is the measure of the potential difference between two half cells in an electrochemical cell. And now continue to Module 4, Nuclear Chemistry. Nuclear chemistry deals with the changes in the nucleus. The nucleus contains protons and neutrons. Radioactivity is caused by unstable nucleus. Too many protons and neutrons may cause a nucleus to be unstable and break apart. Radioactivity causes radiation. Radiation is the emission of energy. There are lots of examples of radiation. Some of them are electromagnetic radiation and nuclear radiation. Electromagnetic radiation encompasses radio waves, microwaves, infrared, visible lights, ultraviolet, light gamma rays, and X-rays. There are only familiar examples of electromagnetic radiation, since we were aware the microwaves can cook food or ultraviolet rays can use sunburns. When people talk about radiation, they always mean nuclear radiation. That is when subatomic particles are emitted in the nucleus of an atom. Nuclear chemistry deals with nuclear reaction or reaction that happen inside atom. Nuclear chemistry may be found in different areas of research, including nuclear imaging in medicine or nuclear engineering in power generation. Nuclear stability. A nucleus is stable if it does not emit particles and or radiator, and if does not change to another nucleus. A nucleus is unstable if they will undergo decay, and the type of decay depends on the reason for the stability characteristic of the nucleus, the principal, subatomic principal, or subatomic particles are the protons, neutrons, and electrons. The protons and neutrons, known as the nucleons, constitute the nucleus. The electrons are located in regions of space surrounding the nucleus, and other are ignored in nuclear chemistry because they are not involved in nuclear reactions. A proton has mass of 1.0073 AMU, neutron is 1.0087 AMU, and electron is 0.005 or 0.0055 AMU. In general, the notation that is used to represent the mass number and atomic number of an atom can be represented using 2 times where A equals mass number, sum of protons and neutrons, and Z is atomic number, number of protons. Nuclear stability means that the nucleus of an element is stable and thus it does not decay spontaneously, emitting any kind of radioactivity. Radioactivity dating or radioactive dating. Archaeologists, geologists, and others involved in reconstructing the ancient history of the Earth rely heavily on radioactive to provide accurate dates for artifacts and rocks, a method that has been very important for dating ancient articles made from wood or clothes is called radiobound dating or carbon-14 dating. Radiocarbon dating is based on the radioactivity of the nuclide 1Nc, which decays via B particle production. 14C equals 14N and Ge. Carbon-14 is continuously produced in other atmosphere when high-energy neutrons from space collide with N-14, 4N plus Nc plus HH. Carbon-14 can be used to date wood and clothes artifacts because the 1C along with the other C isotopes in the atmosphere's reactants with oxygen to form COZ. Radioactive dating is a method of dating rocks and minerals using radioactive isotopes. This method is useful for igneous and metamorphic rocks which cannot be dated by the stratigraphic correlation method. Use the sedimentary rocks. Over 300 natural occurring isotopes are known. Nuclear binding energy and Nash effect. Nuclear binding energy is the amount of energy released when protons and neutrons are bounded together in the nucleus of an atom. The binding energy of nuclei is always a positive number since all nuclei require net energy to separate them into individual protons and neutrons. Nuclear binding energy account for a noticeable difference between the actual mass of an atom's nucleus and its expected mass based on the sum of the masses of its rhombound components. Nuclear binding energy is the energy required to split an atom's nucleus into protons and neutrons. Mass defect is the difference between the predicted mass and the actual mass of an atom's nucleus. The binding energy of a system can appear as extra mass, which accounts for this difference. And that's all about. Thank you and good day, everyone.